Peter Lyons. I'm the convener for Renew Canberra Branch. And tonight we have an exciting presentation from Emeritus Professor Will Steffen from ANU. Will is an Earth system scientist and he's a climate counsellor, and he's going to give quite an in-depth presentation about why the planet is facing a climate emergency. Just before we start, Renew would like to acknowledge the Ngunnawal and Cambry people, traditional custodians of the lands that Canberra is situated on, and we acknowledge and respect their continuing culture and contribution they make to the life of Canberra and the region. Thank you. So I'll hand over to Doug and to Will.
Okay. Thanks so much to all of you for joining us tonight. And as Peter said, I want to talk about the science behind the question of why we are facing an emergency in terms of climate change. Obviously, a lot of us are focused these days on the COVID-19 crisis or emergency, which has taken over certainly in the media and in a lot of people's minds. But it wasn't so long ago that a lot of Australians were out on the streets with signs like this: "We are on fire, act now." So just 3 months ago, we were in the midst of a very deep climate-related emergency. This photo comes just a couple months ago. This is Canberra, the southern suburbs, with the fires, the Namaji fires approaching, and Canberra preparing at least the southern parts of it to evacuate. So it's pretty dire conditions at that time. The satellite imagery shows the extent of the fires along the Australian east coast. And in fact, it was a remarkable area that was burnt. Over 21% of the broadleaf temperate forests in eastern Australia were burnt. An average year, that's only 2%. So clearly this is way, way outside of the average. This is what it looked like on the ground. Fires were as high as 30, 40, 50 meters in the sky. Quite frightening when they're moving in on a community. This is Bateman's Bay in January being evacuated. Many communities along the coastal areas of southern Australia, particularly the south coast of New South Wales, were faced with extremely dangerous conditions and had to evacuate. This is Canberra on the 5th of January. We had the notorious honor on that day of being the most polluted city in the world. We just beat out New Delhi in terms of poor air quality. But that wasn't uncommon for much of January around southeastern Australia, with advisories to stay indoors, not come outside. So this truly was an emergency situation. When we look at the statistics there, the estimated area was about 12 million hectares burnt. As I said, that's about 21% of the area of that type of forest. Fires directly and bushfire smoke indirectly have led to around 400 excess deaths already. Nearly 3,000 dwellings, several villages were destroyed, and over 1 billion animals lost their lives from the fires. We about doubled our annual CO2 emissions. So in other words, on order of 500 million tons of CO2 were emitted during the fires, which is about equivalent to our fossil fuel emissions during a year. So this was an extraordinary extreme event that we went through, the likes of which we haven't seen at all before. Now we can track back why the conditions were there for such an extensive range of bush to burn, why the fires were so intensive, and so on. Anyway, so let's go back to some of the climatic data which stands behind this bushfire season. So you see here this bar on the right. This is the average maximum temperature for the year. So it's averaged over the year and over the entire area of Australia. This was an extraordinary record, over 2 degrees above the 1961-1990 average. So in other words, 2019, the lead up to the fires, was an exceptionally hot year. And look at the distribution. You see this area along the east coast of Australia where most of the fires were. This was the highest maximum temperature on record for 2019. The other thing, of course, that contributed to the fires was that it was exceptionally dry for the 2 years leading up to the fires. So these are the rainfall deciles for 2018 and 2019. And you see that southeastern Australia, including again much of the area that burnt, this was the lowest 2-year period on record for rainfall. So we had this condition of extreme heat with preceding extremely dry conditions. We add this up in an index called the Forest Fire Danger Index, which integrates heat, humidity, wind speed, and antecedent dry or wet conditions. Those dark brown blotches there are extremely high increases in the Forest Fire Danger Index. This is actually looking at a longer term trend, and we see that basically dangerous fire weather has been on the increase in southeastern Australia, and that's driven by the changes in our climate due to climate change. So basically, climate change was setting up these forests to be in a condition conducive to extremely violent, extremely large, and basically uncontrollable fires. That's exactly what happened. What sort of what crept under the radar with both the bushfires and with the COVID-19 crisis was a mass bleaching event on the Great Barrier Reef, which has just been recorded. And you see on this graph on the right, all these red dots all the way down the entire length of the reef were severely bleached in 2020. We recorded the highest monthly sea surface temperatures ever recorded on the GBR. And for the first time, we've seen bleaching along the entire length. But this isn't the first time this has happened. In fact, this is the third bleaching event in the last 5 years, 2016, 17, and now 2020. So basically the gaps between these bleaching events are shortening, and that means it's much more difficult, if not impossible, for the reef to recover. Basically, that's telling us that as climate change intensifies, the Great Barrier Reef is unfortunately on its deathbed. It's going to be virtually impossible for it to get through or to recover from what's happening now and what's already locked into the climate system for the next decade or two. Well, what's behind all this? Well, we know this very well, and that's the change in the global climate that's been driven by human activity. Here we see the long-term record from 1880, where global record started up till 2017, so last year here. And of course, we see a lot of short-term variability, but the long-term trend from the mid-20th century, this 5-year running mean is the red line here, shows an undoubted very strong temperature increase. And we know why that's occurring. If you look at the shape of this curve from 1950 onwards, and then look at the shape of this curve from 1950 onwards, they're virtually identical. This curve is greenhouse gas emissions, actually carbon dioxide emissions from fossil fuel usage and from land use change, basically deforestation. And while land use change hasn't changed much since 1900, certainly again since the mid-20th century, fossil fuel emissions have risen dramatically. And of course, correlation doesn't prove cause and effect, but there's an enormous amount of physics that tell us that there indeed is a cause and effect here. And that's due to the enhanced greenhouse gas effect. As these greenhouse gases, primarily CO2, increase in concentration around the mid-troposphere and lower troposphere around the planet, they absorb more outgoing heat radiation from the Earth's surface here and retain more heat in the lower atmosphere and at the Earth's surface. This has been known for 200 years. This isn't rocket science. This is climate change 101. But it manifests itself in the sort of extreme weather events we've been seeing recently in Australia and in many other parts of the world. We don't want to forget, though, that climate change is not the only major human-driven change to planet Earth that is occurring. Just as dramatic as climate change, but a bit more in the background, is nature's dangerous decline. And that was really put into the spotlight a year ago in 2019, when the equivalent of the IPCC for the biosphere released its large report on what was happening to the living part of the Earth, the biosphere. And the take-home messages are clear. Nature is declining globally at rates unprecedented in human history, and there's all sorts of indicators that they use to talk about the decline of nature or the biosphere. Around 1 million animal and plant species are now threatened with extinction, many within decades. We are on the cusp of the Earth's 6th great extinction event, but the first one that would be driven by a biological species itself, Homo sapiens. And this one I think is quite dramatic. The web of life on Earth is getting smaller and increasingly frayed. And again, this is due to human activities. What I want to do now, though, is put all of this in the perspective of the Earth system as a whole. This is an area of science which has really blossomed in the last few decades. It started really with Vladimir Vernadsky in the early 1900s, but was popularized by James Lovelock. Many of you would have read some of his books and heard of the Gaia hypotheses. But there's a lot of science now behind this. So when we look then, again, sticking with the biosphere for the moment, at what the human transformation of the biosphere looks like, over half of the Earth's surface now looks like this photograph, completely dominated by human activities. When you look at terrestrial vertebrate biomass, now that's the weight basically of everything on land that has a backbone: mammals, reptiles, birds, amphibians. Domesticated animals, 2/3 of the mass is pigs, chooks, cattle, and so on. We humans, just our body mass, we're about a third, about 30%. But that leaves, if you can do the math, only 3% of the mass of animals on land are wildlife, wild animals left. That gives you an idea of how absolutely thoroughly we dominate the land biosphere. Some scientists led by Mark Williams in the UK have published quite an interesting paper on the Anthropocene biosphere, and they make these comments. Global homogenization of flora and fauna. We see it in Australia with extinctions of our natives and with many invasive species. Many of them are domesticates. Humans now commandeer somewhere between 20 and 40% of all the net primary production of the biosphere. In other words, the entire productivity annually of the biosphere, we're co-opting a quarter to close to a half of that. And of course, we're mining fossil net primary productivity. So coal, oil, and gas was once part of the biosphere. It's fossilized, and now we're mining it and releasing its byproducts back into the biosphere. Human-directed evolution of other species, genetic engineering, and so on, and increasing interaction of the biosphere with the technosphere. And that has to do with pollutants, radioactive materials, plastics, all this sort of stuff. But they sum this up quite dramatically, but with quite a bit of evidence, signs of a new third stage of the evolution of the biosphere on planet Earth. The first stage was, in fact, the origin of life itself on Earth. And the second stage was going from single-celled organisms to more complex organisms. But what they're arguing is that humans are now dominating the biosphere to the extent this is now a new stage of biosphere evolution in the history of the planet. But of course, getting back to what's on everyone's mind now, and that's COVID-19 and what it's doing to our societies, the emergency we have now, already papers are appearing that are suggesting there could be a link between human domination, human degradation of the biosphere, and COVID-19 and other zoonotic diseases. The argument goes like this, that direct exploitation of wildlife and degradation of wildlife habitat quality, that is biosphere degradation, have increased opportunities for animal-human interaction and facilitated zoonotic disease transmission, with COVID-19 being the latest example of that. So again, the whole point is we are massively changing the entire Earth system with all sorts of consequences for humans. Climate change is a big one, but there are others. Again, to put this now in a longer-term Earth system perspective, what I'm doing on this graph is going back to a graph that shows you the Earth during the entire period that humans have been on it. So this is ice core data from Antarctica. The red jagged line is temperature inferred from hydrogen and oxygen isotopes in that ice core. And we're going back here to 400,000 years. So this KYR are thousands of years. And you see a very regular pattern of short warm periods and long jagged ice ages. We humans have been through 2 of those cycles of warm periods and ice ages. So we evolved 200 to 250,000 years ago. Hunter-gatherer societies only until this last about 11,700 years that I've circled here. It's called the Holocene. And that's when we've been able, in this period of stability and relative warmth and wetness, to be able to begin agriculture, villages, cities, and so on. But what we're doing to that 11,700 year period of stability now is quite remarkable. I showed you this graph a few minutes ago. This is the global average surface temperature from 1880 and so on. And you see quite a significant rise here. But you don't get the picture of what this really means in terms of the Earth system. To do that, we have to go back to a much longer time frame. And that's what we do here. So this is years since the present. Here's 2000. 2020 is out here. 0 is AD 0. So this is the time of the Roman Empire. So here's the medieval period here. Right about in here is where Europeans first came to Australia. And of course, we settled during this period. And of course, the climate has always changed. We see natural variability throughout this 2,000-year record of global average temperature, but only within about plus or minus 1/10 of a degree, with a very, very slight cooling trend over that 2,000 years. But this spike that I have circled at the end, this is the contemporary climate change driven by humans, driven primarily by the burning of fossil fuels. So you can see how dramatically different this is in magnitude and rate of change compared to the natural variability of the last 2,000 years, and well beyond if I would go back. This is why animals can't cope. This is why fires are getting dangerous. This is why sea levels are rising. This is why we're seeing all the instabilities we're seeing now. This is well outside the envelope of variability in which our biosphere is adapted, to which our biosphere is adapted, and in which we have built our own societies and civilizations. So already this is quite a big hit to the Earth system. But if we look toward the future, these are the model projections that are assessed by the Intergovernmental Panel on Climate Change. So here we are about today, sitting at 2020. So here's the observed temperature increase from 1900. And these are possible futures depending on how much more greenhouse gas we emit. So very low to very high emission scenarios and some intermediate ones out to 2100. But this is only 2 centuries long on this graph. What we want to do again is to put this into a much longer perspective. So here is my 2,000-year graph that I showed you with the human spike now going up into the black up to about here. So what I want to do is put out the 2100 IPCC projections. So 1900 is here, 2000 is here, 2100 is about here. So those projections I just showed you translated onto this graph look like this. So this is a huge spike, the likes of which you rarely see in Earth history going back tens of millions of years. The last time we saw anything near this was about 55 to 56 million years ago, an event called the Paleocene-Eocene thermal maximum. But here we are, a little over 1 degree. We're sitting at about 1.1 degree above the long-term pre-industrial average. And here you see the Paris targets of 1.5 to 2. And here you see those IPCC projections anywhere from 1.5 degrees to going on towards 4 degrees, depending on how much more we emit, possibly even toward 5 degrees. So we are already committed to 1.5. We can't avoid that, given the momentum in our economic system and the momentum in the climate system. But fortunately, we probably still have a shot at limiting temperature rise to somewhere around 1.5 to 2, but only if we really get our act together fast. This is the really dangerous area. This is a extremely rapid temperature rise in Earth timescales. In fact, even for human timescales, this would be a challenge to our contemporary civilizations. And many people think that that could possibly lead to a collapse of our global civilizations. And of course, there are a range of temperatures in between. But some of the most recent interesting science is around this idea of tipping points, which are features of the Earth's system that could put additional CO2 and other gases into the atmosphere, could melt ice and uncover darker ocean water or land and accelerate warming, and in fact, possibly even take the trajectory of the Earth system out of human control and up towards these much hotter temperatures. There's been a lot of work in the last 5 or 10 years on these tipping points and what they might look like. Here's a map of what they look like, and they're sort of color-coded here. We see, obviously, big sheets of ice, the West and East Antarctic ice sheets, Greenland. We also see floating ice, Arctic sea ice, and also ice that's basically frozen peat and permafrost. But we also see big ecosystems like the Amazon and the Great Northern Forest, and also, though, circulation systems in the atmosphere, in the ocean, and coupled systems like ENSO. All of these, we think, can be prone to sudden shifts if they get pushed hard enough or forced hard enough by a changing climate. These arrows indicate we think they are linked. In other words, think of a row of dominoes, and you start knocking over the first couple of dominoes, you could get a cascade knocking over the whole row of dominoes. So the real concern we have is if we start triggering some of these, and some of these we think are vulnerable in the temperature range we're entering into now, if we get those starting to tip, we could get the whole row of dominoes tipping and take us to a much hotter climate, even if we get our emissions down. So this is really a worst case risk that's sitting out there. We don't know how probable it is. We certainly know that we cannot rule it out. We certainly know that the risk is well above 0%, but we need more research to know exactly how dangerous this is and where we might actually start this tipping cascade. So the IPCC actually in its special report on the 1.5 target has assessed many of these tipping elements. And they assess, they call them large-scale singular events, but these include, of course, tipping points. They say already at 1 degree, which is where we're sitting now, there is a moderate risk of tipping some of these, but they say the risk becomes high at 2.5 degrees C of warming. And we're certainly headed with the present emission trajectory towards 2.5 degrees. So this is a real dangerous risk that we are facing. A very recent publication that a group of us published in Nature a few months ago looked at an assessment of what's happening to each of these individual tipping elements. And you see that I think there are 8 or 9 of them here. And in each case, we've assessed just in very simple language what's happening. Greenland ice sheet, ice loss accelerating. West Antarctica, ice loss accelerating. Arctic sea ice, reduction in area. Permafrost, that's starting to thaw. Very dangerously, the Atlantic circulation, which is the linch point for many of these connections, it's been slowing down since 1950s. More frequent droughts in the Amazon and so on. So not only are these tipping elements theoretically possible, we've certainly seen them operating in the past in the paleo records, but even now in contemporary observations, we're starting to see that many of these tipping elements are becoming active. So we made the comment in this paper, and this is a direct quote from this paper, if damaging tipping cascades can occur and a global tipping point cannot be ruled out, then this is an existential threat to civilization. No amount of economic cost benefit analysis is going to help us. So this slide here really summarizes, I think, some of the strongest scientific evidence that we are in fact in a climate emergency now. That these tipping points have the possibility, they certainly put forward the risk of a cascade that could take the climate, the Earth system out of our control into conditions that would be an existential threat to us. Well, if that isn't a emergency situation, I don't know what is. We drew a little cartoon in a paper that was published a year earlier, trying to show what this looks like. And this is just a little stability landscape. So imagine this is a landscape and the Earth is a little ball rolling around this landscape, and time is going from the back of this little diagram to the front. So here's the Earth in the Holocene, this nice warm period of 11,700 years. There's the last ice age, and changes in Earth's orbit kindly pushed us out of that up into this nice little, very pleasant spot to be in. But we humans now have pushed the Earth over here. And this is a proposed new geological epoch called the Anthropocene. But this is now an interesting landscape because it's very shallow. It's not well defined. The Earth is rattling around here. It's moving away from the Holocene. And unfortunately, its present trajectory is taking us toward a future where there may be a cliff or a waterfall. In other words, a position where you fall over this threshold and into a very deep, very hot, very stable valley that we've called hothouse Earth. This basically is the tipping cascade scenario. This is the Paris agreements. This is becoming stewards rather than disruptors of the biosphere. And this would be the 1.5 to 2 degree temperature range. And this would become stewards of the biosphere rather than exploiters of the biosphere. The real issue is, where is this fork in the road? The answer is, we don't know, but we think it could be only decades ahead if we don't get our act together. So again, this is the emergency, is that we're on a very dangerous pathway and we're running out of time to steer the Earth over into another stabilized valley, which we call stabilized Earth. You can look at it in a more standard way of what this climate emergency looks like. This is a graph from the IPCC special report on 1.5, a couple of very low temperature scenarios, obviously requiring net negative global emissions. But in each of these different scenarios, we actually don't hit zero emissions until about 2060 or beyond. And this is what we call in emergency theory, We call this the reaction time, the time it takes to react to an emergency and get the system back under control. So we say our reaction time here is 40 to 60 years from 2020, but 30 years at best. So let's say from 2020, we get our act together in 2050. And a lot of countries now are talking about net zero in 2050. So let's say we have 30 years now to get climate under control. But the problem is the intervention time for many of these tipping points is much less. So the intervention times, what do they look like? Arctic sea ice, it could be zero. We could be right at the tipping point today. What about West Antarctica? That's ice loss is accelerating. It could be only 10 years in the future we hit that tipping point. Amazon, maybe 15. A lot of uncertainty about that. Could be even less, could be more. Greenland ice sheet, that's more stable probably, but by 25 years, we could have tipped that. So all of these are shorter times than the 30 years it's going to take us to get net zero. So this is really asking the question, are we already losing control of the system? Which again points to the fact that we are in an emergency. A nice analogy you can use here is with the Titanic. If the Titanic realizes that it's in trouble and it has about 5 kilometers that it needs to slow and steer the ship, but it's only 3 kilometers away from the iceberg, it's already doomed. It's already lost control of the system. So that's the point we're saying here, is that there is a certain reaction time that's going to take us to get our impact on the climate under control. But we may cross many of those tipping points in the interim, perhaps leading to a cascade. So this is the real climate emergency here. And how are we tracking, dealing with that emergency? Not too well. This is a record of our actual emissions from 1850, estimated, but certainly measured from the early 1900s up to 2019. There have been a few little blips, but it's absolutely clear what the overall trajectory is. It is increasing emissions, and it's increasing emissions at an increasing rate. In other words, it's exponential growth. And yet we have to turn around this really, really fast. In fact, that's how fast we have to turn it around. So the year we peak emissions is really critical. We can't peak them in 2016 because that's already gone. We're up to 2019, we're into 2020. Certainly 2020 will be less than 2019, and that's thanks to COVID-19. So if we can then build on that and use that as a start to a deep emission reduction trajectory and get to net zero by 2040, not by 2050, we will be in the middle of the Paris target, somewhere between 1.5 and 2. So that's our hope. That's what we have to aim for. But if we dither around for just 5 more years, just another electoral cycle or 2 to 2025, then we must decarbonize by 2035 in 10 years. That's impossible. So this, again, is just yet another way to say that we are in an emergency, and that is we cannot miss the opportunity that COVID-19 is giving us. If we go back to business as usual, which some governments are already saying, we will miss the Paris targets. So again, this is just another way of saying we are in a climate emergency. So the students are right. They sense this intuitively. The science actually supports this. We are indeed facing a climate emergency. Here are some of our students standing out in front of Parliament House a year or so ago, linking up with the Swedes there, a nice connection here with IKEA. But this sign here is the important thing. We need system change. We don't need fiddling with this present system at the edges. We need a fundamental shift in our system. And that is the opportunity that COVID-19 is giving us. Greta Thunberg, who was the initiator of the student strikes, has some very hard words to say. Our civilization is being sacrificed for the opportunity of a very small number of people to continue making enormous sums of money. So she's pointing to the inequality, the equity issue. And she says, you are stealing children's future in front of their very eyes. So I'll just turn very briefly to the equity issue and call on some social science data that my colleagues have very nicely given to me. And this one comes from a colleague, Sander van der Loo, looking at what has happened to income inequality. And here we're comparing the English-speaking countries, USA, UK, here we are, and Europe and Japan. So basically starting from 1930 up till the present, 2 world wars and the Great Depression equalized things quite nicely, both in Europe and in the English-speaking countries. And we had several decades of much more equal societies. But since around 1980 or so, inequality has rocketed up, particularly in the United States, but also in the other English-speaking countries, including Australia. Not so much in Europe. They've managed to keep income at relatively equitable levels. So here we have a social issue that is also linked, by the way, to these same economies that are driving the high emissions and the biosphere degradation. And of course, we can track social problems. In fact, one of the most remarkable graphs I've ever seen is this one, based on data showing that as you increase income inequality, you increase social problems. And these are social problems of wealthy countries. They're not related to poverty. They are related to income and social inequality. So here we have a third big pillar of the Anthropocene. We have rapid climate change. We have rapid biosphere degradation. Now we see destabilization of social systems, mainly through growing inequalities. And some researchers here have put all of this together, a beautiful book called The Systems View of Life, a unifying vision. So they're trying to put together all of these trajectories going in the wrong direction that we're seeing over the last several decades. And they make a very powerful statement that our world today is dominated by a global economic system with disastrous social and environmental impacts. They coined the term predatory capitalism. And they note that we are the only species on Earth that destroys its own habitat, or we might say who knowingly destroys its own habitat, threatening countless other species with extinction in the process. So let's now just conclude by saying, what are we going to do about this? How are we going to get things going on the right track? The first thing to recognize, now focusing more on Australia than the global situation, is what is keeping us from getting effective action on climate change. This is known to most people. First of all, it became a political football, particularly with the election of the Abbott government. Divisive politics, there's actually been a lack of bipartisan action, as opposed to, example, the United Kingdom. Vested interest, obviously the fossil fuel sector has been very vocal and very powerful in terms of rejecting or slowing any effective action on climate change. The Murdoch media, Sky News, Australian and so on, has supported these vested interest. Conservative ideologies get in the way, and so on. But I think on the positive side of things, there are really strongly increasing pressures which could form a positive cascade, sort of a social tipping point. And here in Australia, we're starting to see this build already for the case of coal. People are now making the link between extreme weather events, like the barrier reef bleaching, like the massive bushfires, linking coal to the fact that burning fossil fuels, particularly coal, is leading to these climate impacts. On the positive side, we've seen dramatic cost reductions in renewable energy systems to the point where it doesn't make any sense whatsoever to build another fossil fuel plant. In fact, it makes a lot of sense to pension them off as soon as we possibly can. The Rocky Hill mine case, Gloucester, New South Wales, many of you may not have heard of that, but this coal mine was stopped partly on the grounds of climate change, even though this coal was destined for export and not for consumption here in Australia. Investor pressures. Some companies are now starting to cap coal production because they see from a financial point of view, this is a risky investment with more and more pressure from their investors. And there's social pressures with the demonstrations, the students, and so on. So I think we may be getting close to a social tipping point, at least on the case of coal. Globally, what's happening? Student strikes, civil disobedience, increasing pressure on governments around the world to take action. There is a movement now to divest from fossil fuels. This is gaining credibility, it's gaining momentum, and it's getting the fossil fuel industry nervous. Rapid technological development, we mentioned that earlier. Increasing political instability, USA and Australia are cases of this. And this, again, a bit like COVID-19, opens up opportunities when political systems become less stable and less predictable. It gives opportunities for movements to come in and change political directions quickly. Trusted voices are now demanding action, particularly here in Australia. Farmers, fireys, and so on. People who are trusted in the general community are saying, we see the impacts of climate change now. These are unacceptable. We have to take action. And the corporate sector. I sense that there's been a lot of greenwash for a long time. I suspect, or I sense now, that at least there is some talk now of real action, that corporates actually now have to take some positive action. I'll close now by just making a little comparison with the coronavirus, the COVID-19 crisis, and the climate change emergency. What's the same? What's different? All right, there's some quite striking similarities. One is respect the science. This needs to happen in both cases. It certainly happened very quickly in COVID-19. It hasn't happened yet, at least in Australia, for climate change. Act before the real crisis hits. In other words, we've heard this term, flatten the curve, ad infinitum over the past few weeks. That is, avoid the real crisis hitting. We absolutely need to do the same thing with climate change. We have to flatten the temperature curve and certainly flatten the emission curve and in fact turn it around before we hit climate change that we cannot control. That's going to take us to a completely new state of the Earth system. So yes, flatten the curve. And interestingly for the COVID-19, it only took a week or two before that crisis took precedence over other aspects of our society. Amazingly, the economy, sport, education, and so on. The same is true of the climate change crisis. We're now at a point where that has to take precedence over economy, sport, education. So those are similarities, three important ones. Why the COVID-19 crisis and the climate emergency are very, very similar. But there are important differences too. The first one, the COVID-19 crisis is immediate and it threatens humans directly, threatens our health, our longevity, and so on. Climate change is what we sometimes call a long fuse Big Bang crisis, although we increasingly see serious impacts now. Long fuse, it's still building up. Big Bang, it could be far, far worse than the COVID-19 crisis in what it's going to do to humans, our societies, our health, our future, the rest of the biosphere, and so on. It truly is a really horrific future that we could face. However, unlike COVID-19, action to deal with COVID-19 is damaging the economy. It's putting it in deep freeze or on hold or whatever you'd like to say. However, meeting the climate change challenge can lead to a healthier, more dynamic society, and it could actually lead to a more vibrant, dynamic economy. There's been some wonderful work done by Ross Garno, Frank Yazzo, and others, showing that now more than ever we have the technologies. We can envisage the economic instruments and transition approaches that are required, but we don't have the politics to drive this. We need rapid fundamental change and we need it fast. But the point is, this could be really, really positive if we do it well. So what would a COVID-19 type response to the climate crisis actually look like? What would flattening the curve look like? Well, I boiled it down to three things that we could do here in Australia in terms of our COVID-19 type response to climate change. Number one, from today, from now, no new fossil fuel developments of any kind, coal, oil, or gas. Just stop the expansion of the industry. Same thing as stopping the expansion of the virus. We have to try to contain it. Same with the fossil fuel industry. By 2030, we should have achieved a 50% reduction in our greenhouse gas emissions here in Australia. We can go a long way toward that by getting to 100% renewable energy. It is absolutely technologically feasible. It is economically achievable, and it's going to give a lot of positive side benefits in terms of employment, distribution of energy systems, more resilient energy systems, etc. And by 2040, we need to reach net zero emissions. 2050 is too late. If you want to meet the Paris targets, it has to be 2040. So that's a very simple, but I think a very powerful guideline for what we could do to flatten the curve on climate change. So I'd like to end with this little piece that appeared in the internet. The world is saying, the economic world, the political world is saying, there's no way we can shut everything down in order to slow emissions, slow climate change, and protect the environment. And Mother Nature says, here's a virus, have a practice. And that's exactly what we're doing. So I'm going to conclude there. I've talked long enough. I hope that gives you an overview of where we are on the climate change issue. And I think there's an absolutely compelling case. In many different ways, we can declare that now, as we said in 2020, we are in a climate emergency. On the positive side, COVID-19 is giving us a head start. Emissions will drop this this year compared to previous years, but we just have to grab this opportunity to steer our economy in a very different direction as we come out of this crisis. So I'll stop there and over to you for questions and discussion.
Thanks for a very, very informative talk that was brilliantly put together and covered a lot of ground. So I'll get to these questions. We've got a lot to get through. People have been sending them in big batches. The first one comes from Robert. In view of the difficulty of cutting emissions, what is the prospect of carbon dioxide removal to massively ramp up carbon sinks?
Yeah, a lot of people are talking about that. I think the problem there is to really get carbon out of the atmosphere for long periods of time. You've got to use methods that get it away from the active carbon cycle. In other words, growing trees is not going to work, as we found out in Eastern Australia. That's prone to going right back up in the atmosphere very, very fast. So we've got to find ways, carbon capture and storage, something like this. There have been a few pilot projects around the world in terms of pulling CO2 out of the atmosphere by various techniques, compressing it, liquefying it, pumping it down and storing it in an old oil well or gas field and capping it, keeping it away from the atmosphere. That indeed would be an effective way of getting CO2 out of the atmosphere. Right now, it is not feasible at any scale that's close to what's required, and it would be hideously expensive. It's much, much cheaper not to use fossil fuels in the first place than it is to try to capture them from the atmosphere where they're dispersed. CO2 is in its fully oxidized state. And if any of you have done thermodynamics, you know that you're fighting the second law of thermodynamics when you're trying to recapture CO2 and store it away. So it's just a really, really stupid thing to do, in my view. By far the smartest thing to do, and we have alternatives, is just to stop using fossil fuels.
Okay, this next one from Michael Flammer. Will, you said we had similar temperature rise of 5 to 6 degrees during the PETM. Could you maybe clarify again that today's changes are unprecedented, or at least much faster than anywhere any other time in Earth's history?
Yeah, so the PETM was the last time we saw anything, I think, close to the projections I showed if we keep going the way we're going. But it's hard to get a very precise rate out of something that was 56 million years ago, but the best we can see is the rate that we could raise temperature would be an order of magnitude faster than the PETM. So that would be an extremely fast rate of increase, and probably would be unprecedented compared to anything else we've seen in the past.
Okay, from Janita in Evolzen. What impact do you think that COVID-19 and the current oil wars are driving the price of oil into negative areas? $40 on Monday, for instance, negative 40 on Monday. What do you think this will have on global climate change?
Yeah, well, I think obviously oil's actually bounced back already. That was a little blip in the system, although it's still extremely low. It depends on how we come out of COVID-19. There's no doubt that there's a big drop-off in the use of oil and in gas and other fossil fuels. The latest estimate I've seen is that 2020 emissions will be about 5.5% lower than 2019. That estimate could actually go up depending how serious COVID-19 gets and how countries respond to it. So basically what that's due to is the winding down of the economy, which is driven largely by fossil fuels. But if the global financial crisis is any analogy to go by, when we come out of a crisis, and that dropped emissions as well, not quite by 5%, but there was a strong recovery of emissions in the years following the GFC because people wanted to get the economy moving very fast again. So the real key here is that we will get a good start on emission reductions by about 5%, maybe even more, with COVID-19. But the critical question is which direction are we going to go when we come out of COVID-19? We could keep the emissions going down if we use this as an opportunity to completely reorganize our energy systems, start to restructure our economies along the ways that many proponents are now saying are not only possible, they're actually advantageous economically as well. But the other way we can go is some governments are always saying, we want to bounce back to where we were, heavy use of fossil fuels, go back to the old system we had. And if we go back to that system, I suspect that emissions are going to rebound pretty quickly after 2020.
From Robert, oh, sorry, no, it's that. What do you see as the primary barrier to action being taken to avert this climate emergency? From Eve.
I think it's that combination of things I had in that one slide. One is here in Australia, the divisive politics that we have. We don't have a bipartisan approach. That's been proven in other countries to be important to get action. Second of all, we have the fossil fuel industries, big vested industries, very powerful politically. And unfortunately, they are doing everything they can to stop the switch to renewables and so on. And I think political ideologies get into it. It's become an ideological issue, and science has a hard time penetrating that sort of barrier. So that's what's keeping us from getting there. I think the only way we're going to get it there here is a social tipping point, just a massive movement at a whole range of levels that push this seemingly intractable system over the edge, and people have to act, as COVID-19 has already done.
Okay. Why do emission reduction pathways show net zero as a hard floor when the real need for Holocene restoration is massive net negative emissions, i.e. carbon sinks outweighing carbon sources?
Yeah, well, the problem there is, as I mentioned before, is you can't really equate biological sinks with fossil fuel sources. Those are two different types of carbon, if you like. One has been locked away from the active part of the carbon cycle for millions of years, hundreds of millions of years. The other is part of the active cycle and keeps cycling through. So there's a danger in using biological carbon to offset fossil fuel carbon. We already know that. So as we mentioned before, the way to do that is to find other ways of getting CO2 out of the atmosphere and storing it. You may use biological carbon as a waypoint, algae, for example, or terrestrial biological carbon, but then you have to take another step and immobilize that carbon and get it out of the system. And that's the step that's very difficult to do. So the point is, you can probably meet not the 1.5, but close to 2 degrees with little net negative emissions if we have very rapid emission reductions. And that's actually cheaper to do. It's proven we can do it. So that is actually the road we have to take. So it's not a technological barrier. I keep saying this. This is a political and ideological barrier. That's the one we have to fight.
Question from Catherine. How can we encourage the rebuild after COVID-19 to avoid more fossil fuel-based development, road building, weakening environmental standards, and to reduce red tape, especially given mining and road transport industry dominating rebuilding committees and lobbying?
That really is the challenge, and that's very well put in terms of what that challenge is. We need to get a whole chorus of voices out there from all different segments of society saying we want society to go in a different direction. So it can't just be us scientists or activists. It has to be trusted voices. It has to be the rural sector. It has to be the emergency management sector. It has to be the emerging economies. It has to be the people who stand to benefit in terms of employment and so on. So it has to be a cross-society movement saying, all right, the people who want to go back to the old way are the ones, the vested interests that benefit from that. But society as a large is going to lose more than it's going to benefit from that. A better way forward that much more of society will benefit will be a much different economy with different technologies, different social systems, and so on. Part of that has to be a fair transition for those people who lose employment, who are employed in the fossil fuel industry. And that's something that we have to grapple with in the transition. But it can be done. It's being dealt with in other countries in Europe and so on, and we can learn from those. But the point is, we need a broad-based social movement that says we need to move this country in a different direction as we come out of COVID-19.
Question from Chris Moss. Question from Chris Moss. Are methane emissions from gas included in our emissions count?
I think they are, but it's very hard to get a handle on so-called fugitive emissions. I think that's what you're referring to. So basically, our gas industry is primarily for export, but particularly as you go to unconventional gas, there's a much bigger risk of so-called fugitive emissions. That's emissions of gas in the mining process, and that emits methane and other gases into the atmosphere. Of course, they're greenhouse gases. It doesn't take a very high level of fugitive emissions. I think it's only 4 or 5% before gas gets about as bad as coal in terms of its impact on the climate. So that really is a very big issue. It's one of the issues, in my view, that tells me quite clearly gas is not a transition fuel. We're way past that point. We don't need gas. We can go directly to renewable systems, particularly in the electricity sector. So I think we need to really make the point very strongly that gas is not a solution. It is not a transition fuel. We must go to zero carbon systems, and renewables are already out there. They're already as cheaper than gas in terms of new builds.
You, from Chris Sanderson, are you able to put a reasonable probability on which of these two is the most likely scenario given a continuation of the current rate of global politics and emissions reductions? I'm not quite sure what he's referring to.
I think I can guess he's referring to those two pathways I had on my landscape map of stabilized Earth or hothouse Earth. I would say now the odds are in favor of hothouse Earth, unfortunately, when you look around the planet. But one of the things about tipping points, I'll quote my colleague Carlos Nobre, you can never predict when they're going to be. Carlos Nobre is an expert on the Amazon. And he makes the comment, people say, well, the science isn't very certain about tipping points. That's true. And he says, well, you don't know, you don't want to find out precisely where a tipping point lies by tipping it. And unfortunately, that's how you find out precisely where it lies. And that's true for social tipping points too. They're even more difficult to predict, I think, than these biophysical tipping points. Oftentimes you cannot see them coming until they've tipped. And then you say, why didn't we see that coming? So my hope is, and I'm not saying it's a high probability, but it's certainly higher than a zero probability, is that we get a social movement going. The students are certainly trying to get us worked up fast. And we will not see that social tipping point in advance, is my prediction. It'll still look hopeless until suddenly the dam breaks and suddenly coal stocks go to zero and the coal sector is basically out of business in a couple of years. That can happen. Stock markets can move fast. But I think the point is we're actually not going to see that until it happens. And then we will say, why didn't we see that? So I hope I'm right. I'm saying the odds are now not looking in that way. But hopefully we're missing some important social movements under the radar that could push us over in the right direction.
Thank you. One from Dougal Holmes. I remember watching An Inconvenient Truth nearly 15 years ago. Al Gore warning of both going from denial to despair, stop in the middle to effect change. Are we really in control and realistically able to stop the domino effect of the tipping points, seeing what has happened over those 15 years since? What's the most effective action to take?
Well, okay. I think the most effective action is whatever you think is appropriate, whatever you feel comfortable with. Some people are not comfortable with going out in the streets and blockading things. The Extinction Rebellion people are. Some people are much more comfortable with visiting their MP or writing a letter or whatever. What I'm saying is the way to get out of despair, the way to get out of a lack of hope is not to ask someone to give you hope. Nobody can do that. You got to generate it. You got to generate it by getting out and taking action, whatever you're comfortable with. That's how social movements operate. Peaceful demonstrations, writing letters, putting pressure on, talking to your neighbors and so on. That's how social movements build up. And that's what we all have to do. We all have to say, this is now important. This is more important than other things. Spend some time doing what you're comfortable with. Take action, and you will start getting some hope and getting some positive feelings.
How much, a question from Mario Huttenhofer, how much temperature increase is already locked in by the GHG we've already released?
Yeah, if you run the models that way, it's going to be about 0.2 of a degree or so, I think, the last time I looked. So since we're sitting at 1.1, which is what the World Meteorological Organization released a couple of weeks ago, we're already committed to 1.3, 1.4, I think, with the emissions we've already got in. And that really is based on an equilibration with ocean and atmosphere. Oceans store about 90%, a bit more than 90% of the heat. They're very slow moving compared to the atmosphere in terms of circulation. It'll take a while for them to equilibrate, and that's where the extra heat's going to come from. It's already there. In terms of the 1.5 degree Paris target, I don't think we're going to get there because we're locked into 1.3, I think, at a minimum. We can't get emissions to zero tomorrow. I think the best we can hope for is a 2040 net zero, and that'll take us somewhere between 1.5 and 2. But hopefully that'll still be a manageable planet, although it's going to be more difficult to live in than the one we've grown up in.
Yeah.
How are you going as far as your stamina, Will?
I could take a few more.
A few more? Okay. We'll move on to one from Mario Huttenhofer. Negative emissions. How do you do this realistically? By technology, reforestation, which is the way to go, which is most important?
Well, I think technology is the way to go. As I said before, reforestation, that carbon's vulnerable to going right back up the spout with fires, with changes in policies and so on. We've actually seen that in Australia. There are some exceptions on biological carbon. One may be macroalgae, big algae in the ocean. The deep ocean stores a lot of carbon and it's locked away from the atmosphere for long periods of time, almost geological periods of time. So if we can somehow, we haven't worked out how to do this, if we can somehow get carbon back into the marine biota and get that to start sinking down into the abyssal parts of the ocean, we may have some solution. But none of that is even close to being feasible at present. And by far, the most feasible action we've got is switching our technologies away from fossil fuels. That's far, far more feasible than any of the carbon capture and storage technologies.
You. One concerning sequestration from Dougal Holmes. Do we need sequestration to remove greenhouse gases from the planet's atmosphere as well as reaching net zero emissions by 2040? Or do these gases eventually dissipate on their own?
Well, yes, I referred to that. A lot of these gases will go back up if you just store them in terrestrial ecosystems. However, I will say that if concomitantly we can get climate stabilized, get our other emissions down, restoring the biosphere is a very, very good thing to do. But I would argue strongly against monoculture plantations. And I would argue that the real reason you want to get carbon back into the terrestrial biosphere is not really for the climate change issue, it's for trying to restore the terrestrial biosphere. And that means having the patience and the ecological understanding to restore complex ecosystems that were there, or rather that will be well adapted to the new climate, rather than simply a quick fix of spending a couple bucks on a carbon offset scheme on an airline and someone whacking in some fast growing pine trees. That's not a solution at all.
Right. We might move to one by Ben Mitchell. What sort of investment is required to achieve 100% renewables by 2030? And how would that compare with business as normal?
Yeah, I don't know the exact numbers. What I do know is that if you need to replace, and many of our old power stations, fossil fuel power stations, are at or near the end of their lifetime. So the question is, and we obviously need to keep our electricity supply up and perhaps increasing as our population increases. So the question there is, what do you replace them with? And there, in terms of new builds, there is a lot of evidence to say it's actually cheaper to build renewables than it is to put in a new coal-fired power station or even a gas-fired power station. The other point is having a distributed grid with many power sources and a smart grid which can move the energy around quickly to where it's needed, fast and efficiently, is actually more resilient than the one with a few big power stations and lots of wires in between, as we found out in the storms in South Australia a few years ago. So you build a more resilient system, you get emissions down, you employ more people, and you save money. We're 100% renewable here in Canberra, and we have some of the lowest electricity prices in Australia.
Thank you. Question by Energy Lab Australia. Starts off with a thank you for your time and great appreciation. Question, you speak of social tipping point around the issues of coal, but there are politically important areas of Australia that are more passionate and steadfast in their support of coal than ever. For instance, rural communities relying on those jobs, like in northern Queensland. how do we balance the politically heated arguments of jobs in coal versus climate change?
Yeah, that's a good question. And I think that's the sort of question they've struggled with in places like Germany and Poland and places like that that have had big coal industries. I think the way you've got to handle that is you actually, before you go in and make these transitions, you actually have to have a plan. You have to consult with communities. You have to work out a fair transition plan so that there are jobs for people who who lose their jobs in the coal industry and so on. I feel far less sympathy for the big companies who are very wealthy, and for the investors who are very wealthy. They can move their money and quickly and make their money somewhere else. But I do think we really need to look after the social issues associated with a transformation like this, and that is key. I think that's probably a more difficult thing to do than the actual political pressure, which can come from large areas around the country who are feeling the impacts of climate change, who've suffered from the bushfires, the tourist industry who suffered from the loss of the Great Barrier Reef and so on. They've lost far more jobs than the coal industry provides. So we need to have a bigger picture. Governments need to have a bigger picture of winners and losers and of the climate change issue. And they need to actively support this transition in terms of supporting workers and supporting communities that have to make this transition.
Thank you. Perhaps make this the last one, Will?
Yeah, that's fine.
Probably a good one here. Is there an exemplar nation that you would like to see Australia emulate in response to the climate emergency?
There are aspects in other countries I would like to see us emulate. One is across the Tasman in New Zealand, where they now have bipartisan support for a net zero carbon bill. Obviously, they have some hard work to do on the agricultural sector over there, but they're making progress. I think countries like Sweden have done a pretty good job. Countries like Germany have done a good job. No one's perfect. No one's got the answer yet, but as colleagues of mine say, there is no silver bullet out there. There's only silver buckshot. And you can go around the world and find examples of countries that are doing at least part of it very well.
Yeah, indeed. Well, there's many more questions, but we might try, obviously this will be made available from this point on in video. Thank you very much for all your hard work and the input into the presentation, Will.
Okay, thank you, and thanks to Renew for hosting me tonight.
Thank you, much appreciated from you.
Okay, bye-bye everyone.
Bye.